Okay. All right. So set 1 minute up. We'll see that the pellet is at the bottom, and what I'm going to do is aspirate off the supernatant, and then I'm going to spin it very briefly just to bring down any little bits of any remainder of supernatant. So I've got my aspirator. I'm going to suck off. You don't have to get all of it off in the first one because we're going to do it spin a second time. The problem is there is significant amount of supernatant still sticking to the sides. And so if you look at how much, this is for number 2, you can see how much supernatant I've got left behind. And after spinning a second time, you'll see that significantly more will come down. That's just a few seconds spin. And this is number 2. You can see that there's more supernatant that has been brought down compared to before. No, that's it. Thank you. I'm now going to aspirate off as much of the supernatant as I can without picking up, the pellet itself. Okay, so you can see it's relatively dry. Okay, so now I want to resuspend the pellet, each pellet in 150 microliters of TE1050, 10 millimolar trischloride pH 8, 50 millimolar EDTA. The relatively high concentration of EDTA is there to chelate any divalent ions which are necessary for nucleases to act. And this is a potential problem because the RNAs that we use may have nuclease contamination. I actually forgot to thaw out my RNA solution, so I'm going to do that now. Thawing out my RNA solution as well as my phenol solution. Okay, so if I were to simply take a regular P200 with 150 microliter, with a tip, one of these white tips that we use, it's got a very narrow edge tip at the bottom, and it's difficult to resuspend to get the pellet to travel through that small opening. So instead, what I'm going to do is I'm going to cut off the tip of the white tip. So remove just a little bit. Okay, so you can see now it's got a wider opening compared to before. I'm going to take my TE1050 solution. I'm going to add 150 microliters to each tube. And now I'm going to resuspend. And the way I resuspend it is I'm blowing at the pellet, and I'm actually trying to grab onto the pellet. And as it travels through the tip, it gets broken up. And because it's mostly nucleic acid, it goes into solution very easily. But it has to be broken up to dissolve properly. So you can see within a few seconds, that pellet is starting to disappear. The solution is becoming more milky. And I want to resuspend this to the point where I don't see any clumps, where it's essentially a homogeneous solution, at least a suspension. So that's the resuspended sample. That's sort of what it usually looks like. And I need to do this now for the second one. Same idea. I'm going to cut off the tip to have a wider opening. And then I'm going to resuspend by pipetting up and down, blowing at the pellet, and actually trying to grab onto the pellet so that as she travels through the tip, gets broken up and then dissolves. If you know what you're doing with this step, it should only take a few seconds, 20 seconds to dissolve each pellet. If you try and do it through a narrow tip, it could take minutes to do it, to actually get it to resuspend. Now, sometimes you'll have a bigger pellet and it takes a little bit longer to get it to resuspend. And you might have a little bit left over in the tip, but that's sort of what you're looking for. Okay, so I've got my samples resuspended, and now what I'm going to do is add the RNA solution. Remember, most of the nucleic acid that's in these tubes now is actually RNA. We need to chop those RNA bits, mostly tRNA. We're going to chop them up into much smaller pieces. Here's my RNA solution, not a lot left in this tube, and I'm going to add 1.5 microliters to each tube. I'm flicking it to mix it. I could vortex it. Actually, I'm going to go ahead and vortex it briefly before putting it into the water bath at 37 degrees. I'm going to let it sit here for 15 minutes, and then we'll do the next step, which is to extract the phenol.